The birth of stars is one of the most fascinating and complex processes in the universe. It is an amazing transformation of clouds of gas and dust into giant stars that shine in the sky. The process of star birth can take millions of years, and it depends on many factors such as the cloud's mass, temperature, pressure, and even interaction with other objects in space. Let's take a look at how this process works from start to finish. It all starts in molecular clouds, huge and cold gas objects consisting mainly of hydrogen and helium, as well as dust. These clouds are very dense, and the temperature in them can be very low, around 10 to 100 Kelvin, which are very cold conditions by human standards. However, these clouds are not static. They are in constant motion. When parts of a molecular cloud are compressed due to gravitational fluctuations or collide with other gas clouds, it starts to increase their density. Over time, these compressed areas of the cloud, made up of gas and dust, continue to shrink as gravity draws them toward the center. When enough gas and dust are gathered in one place, a so-called gravitational collapse occurs. This means that the parts of the molecular cloud begin to fall on top of each other under the influence of their own gravity. As a result of this collapse, the temperature and pressure inside the compressed object begin to increase. At this stage, the star is not yet active, but the process of its formation begins. Gravity will pull gas and dust particles toward the center, and eventually a small and hot object called a protostar will form. A protostar is a stage between a molecular cloud and a full-fledged star that is just beginning to be born. A protostar is not yet a star, but its structure is already similar to what it will become in the future. It consists of gas and dust, which are very hot and begin to shine with a weak red light. This light can be seen in the infrared spectrum and is usually detected by space telescopes. This stage lasts several million years, during which the protostar gradually gains mass and size. During this period, the temperature inside the object increases, and when it reaches several million Kelvin, the first thermonuclear reactions begin. At this stage, the temperature and pressure inside the protostar reach the critical values necessary to start thermonuclear reactions. This is a process in which hydrogen atoms combine into helium, releasing a huge amount of energy in the form of light and heat. This is the key moment for the birth of a star. The fusion becomes self-sustaining, and the star no longer depends on external processes for energy. It begins to emit light, and from that moment on, we can call this object a real star. When the thermonuclear reactions stabilize, the star reaches the mature phase. It is located in the so-called main sequence in the Hertzsprung-Russell diagram, where most stars, including our Sun, are located. The star steadily burns hydrogen in its core, radiating light and heat for billions of years. This stage is the longest in a star's life. For the Sun, this period lasts about 10 billion years. However, stars with more mass burn their hydrogen much faster, and their life cycle lasts only a few million years. Over time, the star uses up its hydrogen in the core and begins to use other elements for fusion. When the hydrogen is exhausted, the star moves on to the next stages of its life, which may include expanding into a red giant and then dying in the form of a super explosion, supernova, or collapsing into a black hole, depending on the star's mass. But at this stage, the star has already completed its main mission, birth. It passes on larger elements such as carbon, oxygen, and iron to its offspring, which then disperse into space, forming new generations of stars and planets. The birth of a star is a complex and long process that involves many physical and chemical transformations. From a cloud of gas and dust to a full-fledged star that radiates light and heat, this process takes millions of years and is accompanied by numerous stages. Stars not only illuminate our universe, but are also the basis for life on the planets that form around them. This impressive phenomenon is proof of how dynamically and constantly the cosmos is changing, and each star we see in the sky tells us its own unique story of birth and existence.